Alright, year 11, so let's continue with and finish chapter 13, which is applications of trigonometries. In this situation, what we're looking at is planes in 3 dimensions, and further down in problems that link to 3D. Here with that diagram, you have 2 planes that annotate pi 1 and pi 2. As they intersect, they will form what we call a common line. P will belong to that common line, and A and B will be respectively on planes pi 1 and pi 2. We want those lines PA to be perpendicular to the common line, and the same for PB. And we annotate the angle theta, the angle between PA and PB. Commonly what we have is one plane will be horizontal. So if we have pi 2, the blue plane, to be horizontal, PA will be annotated as the line of the greatest slope. So let's look at a few examples. So first example, again, just pause that video, read the problem, look at the diagram, and come up with a few diagrams to elaborate your steps. So let's continue. First thing, as you can see, is annotate your triangle, which is in red, as you want to figure out the angle for that theta for that red triangle. You will need to have 2 steps. The first one is looking at the rectangular base that will allow you to find the length A to B prime. And once you've done that, you can go on to the vertical triangle, which is the one in red, and you have annotate the vertices. You will have the opposite side and your angle theta. So it's critical that you do those sketching with the values that you need to find out, and also annotate the vertices. So here's the working out to find A to B prime, and that will give you your expressions in terms of A. Then what you can do is, using one of the trigonometric ratio, in these situations will be your tangent. You will have tangent of theta in terms of A, and that will cancel out, and I will give you your required angle in degrees to the number of decimal places. Okay, just hold on. Alright, so now for part B, we you just need to annotate the angle phi, which is the angle between the 2 planes. So you can see that for ACD prime, we're going to use the line AM, and for DCD prime, which is the horizontal one, we will use the line DM. And then you can express the find the first one of the sides, which is DM. We express it in terms of A. Then we can use the tangent phi. That gives you an exact value without the A value, and we get the angle by using the inverse tangent. Alright, next example. So again, pause the video, have a look, read the descriptions, and see what you need to find out. Alright, let's continue. we need to find the height of the tower, which is PQ. There's a few informations given to you. You know those angles from the top of the tower to the point ABC, and we know the length AB and BC. So to simplify, we have here an expression of H, okay, for all those sides. So this is the horizontal plane at the bottom of the tower. We can express now all those sides in terms of H, which is we can annotate over here. And then what we're going to do is use the cosine rule in different triangles. So in the triangles AQB as well as CQB. So we get those two cosine rule, which is we make cos theta the subject. As we make them equal, we get an equation in terms of H. We simplify, which is just bring it back down to a quadratic. In this situation, it's just a perfect square to be equal, and it gives you a height of 5 meters. Next one. So again, pause the video, come up with a diagram and annotate the dimensions. So here you have your diagram, which is a sphere which is on top of a cylinder. You also annotate a few extra dimensions in here. So we just simplify that as a two-dimensional diagram. In that triangle, right angle triangle OBC, we annotate OC. That's coming from our properties. We know BC, OB is the radius. Use the Pythagoras theorem, express in terms of R, and we find that R is 5 centimeters. Alright, next one. Again, just pause the video, just come up with a diagram. Let's continue. Alright, so to find the percentage of spaces inside the box, it's going to be the that void space between the spheres. Okay, so even if you have an unknown, we can determine quickly the radius, which is given here. And then what you do is you determine the volume of the box, the volume of the golf balls. You do the difference between the two volumes of the boxes from the golf balls, which is here. You divide by the volume of the boxes, you multiply by 100, and I'll give you your percentage. And that's it for this chapter. See you later.